Hi everyone, Kent Barber here. This is a little update to the Jetfluids plugin. This is now about 10 times faster on the Windows machines because it's using the Intel threading building blocks, a little library. And on OS X that has not changed yet, it's still using the same. But OS X I found always simulated a bit fast with its multi-threading anyway. So what we're seeing here is just the simulation on a run. I just want to show you a couple of other simulations that were made. So this one here was simulated in about 6 minutes. It's about 100 by 100 by 200, I believe, block at a grid resolution of 2. Another one here, similar thing. And this one here is actually rendered out to OpenVDB, and then it's meshed using the Cinema 4D mesher. This one here was meshed using, was exported out as C4D files for each frame, and is meshed using the fluid simulation meshing system itself. A couple of other little simulations that I can show you is this kind of breaking beach wave simulation. This is done at a resolution of grid size 1 by 1, so that's got quite a lot of detail in there. It took a bit of a time to simulate out. And one other demo that I can show you is a smoke. So this was actually rendered in Redshift. So in this particular example here, the scene was exported out as VDB files for each frame to disk, and then brought into Redshift and rendered using the Redshift renderer. I just want to take you through some of the options now that have just been added. So I'm going to quickly just close that all down. And I'll just make a new one. Now, one other thing to note is at the moment there's some offset issues. So don't move the scene around. Don't move the fluids around. That may not work if you scale it up or move it around. But you can resize it. You can come in and you can change it using the sizes here. So if we change that to 100 by 100 or 200 or something like that, then you can resize that. And changing the cell size obviously will add more cells to the volume, and it'll be slower to render. But anyway, the first things that I want to show you here is just want to bring in an object. Doesn't matter what it is. Let's bring this in, and I'll just put that under the emitter, drag that under as the object, and I'm going to keep this as one shot. And in the fluid now, we have an extra option called smoke. So this is one of the first things that I'll just show you here. So I'll just scale this down actually. And we'll bring that across. Put that about here in the scene. And under caching, well, this is a new section you'll see. You'll see that the caching's been removed from here. So to do your simulation, it's actually now under the cache tab. This may be renamed to simulate or something later on. And under here, you now got a Dropbox, which actually has external file in it. So if you leave it as internal, then every time you simulate, it's going to be storing the data in the scene itself. So your scene might get up to like 1 gigabyte in size. So now you can choose external, and you can choose where you want to write your file to on disk. So I'm just going to write it out there. So what it's going to do is it's going to create a file called test file underscore, then it'll be 5 numbers like 0001, 0002, 0003, and that'll either be a VDB file or a C4D file. And that is dependent on what you choose here. So if you're choosing particle or mesh, it'll write out a C4D file for every single frame. If you choose volume, it's going to write out a VDB file. So now if I go and start simulating that, what it's going to do is create a VDB file, and you can see it actually happening in the viewport here. It's starting to, it's coming out of this fluid is being represented in here as a volume. So if you wanted to, you could volume mesh that, although you wouldn't really volume mesh these fluids. The smoke, you would volume mesh the fluids rather than the smoke. Smoke is best left as a VDB, but anyway, you can use that if you want there. So let's bring that back out. And on disk, here you can see it's written out all the VDB files for each one of those frames. So instead of doing a smoke, you may want to obviously do fluids. So the grid level set liquid works really well with the threaded building blocks. And I've noticed a remarkable speed up on my Windows machine. This is a 10 core machine here. So I'm just going to clear that cache, and I'm going to leave that as volume again, and I'm just going to start caching again. So let's just actually bring this up, and I'm going to change the emitter to be, oh, it is one shot already. So the smoke, that was just one shot as well, but if you wanted it to continually emit smoke, you turn one shot off. Just a point to note there. So let me just make this a bit bigger. And I'm just going to simulate that, how that is there with the grid level set, and I'm just going to start caching. Now you notice with the VDB, it's whited out immediately. Now the reason I've done this for now is just because I've had to invert it so that I could get it into Redshift. So if you're going to use this in Cinema 4D, you can put it under a volume measure. Put that under a volume measure, and you just come in and you can change that to ISO, and you'll see the fluid there. And I'll just hide the sphere in here, and now I'm just going to stop that caching. And if we just rewind, you'll see it's been meshed by the volume mesher in Cinema 4D. So without the volume mesher, it's going to look like this. Now the reason I've done that is because purely when I bring these VDB files into Redshift, they work better when it's in this kind of way. But I'm going to try and look at improving this so you can actually see the volume in Cinema 4D as well. But for now, that's what you'll see. And just make sure you put it under a volume measure to be able to use it in Cinema 4D if you want to. Now, if you don't want to use VDB files, then you just come up to your fluid again. Let's clear it. And we'll change the display to mesh. Now it's going to use the internal mesh representation. I'm going to turn off this fake particles because I don't want to actually show particles for this, and I'll remove that volume measure again, and now I'll just start caching it. So now it's going to use the mesher within Cinema 4D itself. Now if I bring across that folder here again, you'll see that the test files are being created as C4D files. And it's one per frame. And now I can stop this, and let's rewind it, and let's just play that again. And there's the file there. So what it's doing when you play back is it's loading in every single C4D file every frame, and it's happening within this fluid system as well. So that will be updated in your scene. Okay, that's really it from this at the moment. It's just the speed up. It's the caching for caching to external files. The support for volume under this type that will create a VDB file. And yeah, just the speed up there. Now, a couple of little things down here is when you're using smoke, you do have some actual settings for smoke. But I won't go over these settings right now. But you can play around with them if you want. But if you do, just make small adjustments to them. You know, don't well, you can try big adjustments as well. It won't affect the simulation time, but it'll affect just the way that the smoke and temperature works. That's another point to note is currently if you export out the smoke to a VDB file, you'll get a density and you'll get a temperature. These look very similar at the moment. I'm trying to figure out why they are so similar, but yeah, in theory, you know, you can use both of those in Redshift to do different things when you're setting up your materials. If you're exporting out a plain fluid, it'll just have a density in the VDB file. Alright, that's enough for me. That's 8 minutes. So have fun with that, guys, and yeah, I'll get another update to you when I have some time. Cheers.